concept of EIGRP.
IGRP is a classless and hence distant vector protocol that gives us a real edge over another syscall proprietary protocol, Integral Gateway Routing Protocol (IGRP). This is EIGRP message format. The data portion of EIGRP message is encapsulated in packet called type length value (TVL). TVL type includes EIGRP parameters, IP internal routers, and IP external routers. This EIGRP parameters TVL. It delivers metric rates, the K numbers, by default. Only bandwidth and delay are weighted, K1 and K3 respectively. Delivers hold time, the amount of time that receiving neighbor should wait before considering the advertising router down. This is the IP internal message. IP internal message is used to advertise EIGRP routers within an autonomous system. Important fields include matrix fields, delay and bandwidth, subnet mask field, and destination field. Now I show you hello packet. It is used to discover neighbors and form adjacencies with those neighbors. It are multicast and use reliable delivery. For the update packets, I use to propagate routing information. We send only when necessary. Acknowledgement packets are sent when reliable delivery is used. Reliable delivery is used for update, query, and reply. The diagram shows you used by doer when searching for neighbors and other tasks. Use reliable delivery for every query. There is an acknowledgement. For every reply, there is an acknowledgement.
EIGRP metric calculation. The next part, we will discuss about EIGRP metric calculation. The first part, we will discuss on EIGRP composite metric and the K values. EIGRP uses the following values in its composite metric, which are bandwidth, delay, reliability and load. The formula used has values of K1 to K5, which are K1 and K3 are equal to 1, and all the other K values are equal to 0. We calculate the metric by using the default composite formula in such a way that K1 multiply the bandwidth, then we add the result with K3 multiply the delay. The complete composite formula can be calculated as shown in the figure. In addition, the K values can be changed with the metric weights command. To verify the K values, we can use the show IP protocols command. In this example, we can see that the EIGRP metric weight values are stated as K1 and K3 are equal to 1, whereby the other K are equal to 0. To view the EIGRP metrics, we use the show interfaces command of serial interface. There are 4 EIGRP metrics features. The first one is bandwidth. The EIGRP uses a static bandwidth to calculate metric. Most serial interfaces use a default bandwidth value of 1.544 Mbps, which known as T1. The second one is delay. Delay is defined as the measure of time it takes for a packet to traverse a route. It is a static value based on link type to which interface is connected. The third one is reliability. Reliability is not a default EIGRP metric. It is a measure of the likelihood that a link will fail. It is measured dynamically and expressed as a fraction of 255. The higher the fraction, the better the reliability. The last one is load, which is also not a default EIGRP metric. Load is defined as a number that reflects how much traffic is using a link. The number is determined dynamically and is expressed as a fraction of 255. The lower the fraction, the less the load on the link. EIGRP metric calculation can be done using the bandwidth command. In modifying the interface bandwidth, we can use the bandwidth command. For example, we enter bandwidth kilobits. In the global configuration mode, we use the show interface command to verify the bandwidth. In this figure, the actual bandwidth of the link between R1 and R3 matches the default value for serial interfaces, which is 1544 kbps. Note that the bandwidth command does not change the link's physical bandwidth. In this part, we will talk about EIGRP metric calculation using bandwidth delay. To calculate the default metric, we must multiply K1 with the bandwidth. Then, we add them with the result of K3 multiplied to delay value. In this part, bandwidth is defined as speed of slowest link en route to the destination, whereby delay is the sum of the delays of each link en route to the destination. Then, we use the show IP route command to verify the EIGRP metric. EIGRP uses the lowest bandwidth in its metric calculation. The calculated bandwidth is equal to reference bandwidth divide the lowest bandwidth in kbps. EIGRP uses the cumulative sum of all outgoing interfaces. The calculated delay is equal to the sum of outgoing interface delays. The final EIGRP metric will be the calculated bandwidth plus the calculated delay. In this example, we can find the values of slowest bandwidth and the delays. First, we must find the slowest bandwidth by using the show interfaces command in each router. For example, the bandwidth in the R2 router is 1024 kilobit. Then, we calculate them using the default metric formula. In finding the delays value, we can use the same step as mentioned in finding the bandwidth values. We entered the show interfaces command in each router to get the delay values. Then, we calculate them using the default metric formula. Then, we can get the final value of EIGRP metric by adding both bandwidth and delay values. To verify the metric value inside the router, we can use the show IP route command.
Diffusing update algorithm. We also can call it dual. DUAL. Dual is the algorithm used by Cisco Enhanced Interior Gateway Routing Protocol (EIGRP) to ensure that a given route is recalculated globally whenever it might cause a routing loop. This is the example for diffusing update algorithm. Now we have given 5 routers and each router connected by link, and the number inside the bracket is metric of link. Now a client on router E want to talk to a client on router A. The immediate neighbor of router E are router C and router D. Dual in router E asks for the reported distance from router C and D, respective to router A. The following are the results. Destination router A via D reported distance is 4 and router A via C reported distance is 3. The router via C is therefore in the lowest cost. In the next step, the distance from router E to the neighbor are added to the reported distance to get the feasible distance FD. The following are the results. Destination router A via D, the feasible distance is 5, and router A via C, the feasible distance is 6. Dual therefore find that the route via D has the less total cost. Then the route via D will be marked as successes, equipped with passive status and registered in the routing table. The route via C is kept as a feasible successes.